Here, the ADF stands for automatic direction finding. Automatic direction finder. And the NDB stands for non-directional meter. Okay. ADF and NDB, automatic direction finder and non-directional people. NDB is a ground station which will send the signals. This is a ground station, or you can say it's a transmitter. This will send the signals, and ADF will be in the aircraft equipment or receiver. Okay, NDB will be sending the signals from the ground. It is a station, and ADF in the aircraft. The equipment in the aircraft is ADF, which will receive the signal and give the information to the pilot as required. Okay. So this NDB will emit the signals in vertical polarization. So it will emit a vertical signals, not horizontal signals. It will emit a vertical signals which will be in all the directions. Then the NDB will receive the signal and it will amplify or take out the information and give it to the pilot and display the information. Okay. It will work in low frequency and medium frequency bands. Low frequency and medium frequency bands. Okay. The frequency for NDP will be 950 to 1750. Let me check one second. Let me confirm this. Yeah, it is 1950. Sorry, not 190. 190 to 1750 kilohertz. It will work in this range. And the ADF will be working between 190 to 450 kilohertz. Okay, these are the two options, two frequency ranges. You'll have to remember the frequency range of every equipment also. What range this equipment works in.
Sir, but this ADF doesn't process that above 450 frequency, then why they will be using such big band?
They'll use it for voice navigation and all other things. EDF is the instrument which will give you the bearings, but they also have to send the voice signals and distress signals. And also, signals can all be sent beyond that.
Okay, that thing works in all conditions like other equipments.
Not other equipments, same equipment. See, ADF wants to give you the bearing. I'll tell you what bearings are. Okay, it will look kind of VOR only. I'll tell you what it is. It will give you the generally bearing in the sense the direction which side you want to go.
Okay.
Okay, now you want to hear the voice. If you are tuned into the correct signal and all those things. So for that you need voice VHF frequencies and all that. So such different range will be used. Okay, when we go through the chapter, you will understand step by step. But generally, remember the frequencies of each and every instrument or equipment I am going to teach you. Okay, so what do you do is whenever you want to switch to some you want to switch to some station, you will find the frequency of that station on the map. When I say station, here it means NDB, NDB stations, wherever they will be placed. Now you want to switch it to some NDB. So you will first figure out the frequency of that NDB from the map. Now you know the frequency, you will set that frequency on your ADF. That ADF, once you set the frequency, will give you a Morse code. There will be a button. If you press that, it will give you Morse code. Morse code will be in voice. You will hear this, toom, 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 like this, right? You'll hear that. So when you hear that, you will first that map will have a frequency written on it. Let's say 235 kilohertz is the frequency of that station. When you press tune in 235, you will first press that button and hear the Morse code and make sure that Morse code of that station matches with the Morse code on your map.
Okay.
Just below the frequency, there will be Morse code mentioned for that station, whatever it is. You switch it, then you press the button, you listen and make sure this Morse code is correct. Sometimes you might be getting information from different NDB which is who are also working on the same frequency. You might, especially when you are flying at higher heights, you might switch into two or more than two NDBs of same frequencies.
Okay.
In such cases, that's why to make sure you are switched into the correct one, you listen to the Morse code and identify you are on the correct station. If not, don't don't listen to that. I mean, don't depend on that.
Sure. It's chapter 9, not everything. Your indigo, your indigo syllabus also. It's okay, open some market.
Sorry for the where was I?
So the NDB, Morse code.
You'll listen to the Morse code only if it is correct. You will go ahead with whatever is reading and whatever you got to do. Okay. Uh, Whenever there is an NDB station, let's see the NDB station.
So every airport will have a NDB station.
No, it's not the airport. NDB can be anywhere.
What is the this thing, transmitting radius station on it?
That depends. Wait. It will transmit everywhere, but it depends on the energy. How much energy you give, that much far it will go.
Okay.
Okay. Now this energy might also depend on the disturbances. If there are disturbances around, that it might not go how far it is supposed to go. Right? Radio is, if you keep sending it, they can go as long as they want. But you should have enough energy to send it how far you want that to go.
But my question is like now many advanced systems are there, like satellite communications.
This was before that, no?
Okay. As of
NDBs are not used in use as of now.
Oh, okay.
But we still have to study all the equipments we use on. Some parts, it's not like completely gone. There are few places where they still use old NDBs.
In Cessnas or not?
It's not about Cessnas. NDB is a ground station. If you have a receiver in your aircraft, You can use it in any aircraft. Okay?
In Cessna now they'll be using satellite communication.
No.
NDB.
We or they might use GPS if it is a glass cockpit and they have this Garmin 1000 installed. You can use it. It depends. Now it's like asking sir, आजकल सारे क्लास cars में वो middle screen आता है क्या? That screen with GPS. That depends on the type of car you buy, na. If you still have your old vintage car, will it have it? No. It's similar. These are instruments which came with technology. That now what technology you wanna put in your aircraft, that's up to you. NDB station. So NDB station looks like the vertical pole. These are all different NDB stations. Maybe I have a presentation. Let me show one. Forward time. Automatic direction finder equipment in the aircraft is used in conjunction with the simple low and medium frequency non-directional people on the ground to provide an aid for navigation and for non-precision approaches to airfields. It will also give you the navigation, help with the navigation. Also, when you say non-precision, there are two types of approaches. Like based on the equipment, precision approach and non-precision approach. Precision approach is usually given by ILS, MLS. ILS is instrument landing system. It will precisely bring you on the runway, even if you can't see anything in front of you. MLS also. Even GPS will precisely bring you on the runway. But VOR, ADF, and all will give you a rough idea of where the runway is. They can't put you exactly on the center line. That's why we say non-precision approach. Okay. So this is a NDB station. This is how it looks on the ground. It will be sending these vertical waves like this from all of its antennas in all the directions. Okay, and you will have a receiver in your aircraft. That receiver will take this information, these signals, and it will tell you which direction are you in. All those things. The NDB is ground-based transmitter which transmits vertically polarized radio. Okay, that's all. When an aircraft ADF is tuned into NDB frequency and its person identifies the direction of the NDB being indicated. Yeah, a cone of silence exists over the NDB transmitter. This is what I was going on. So whenever, see you see the design, right? They are sending the signals in this way, correct? In all the direction. But what about right above it? It won't send the signals. So when you are right, you are flying through an NDB and you come right above it, there will be a cone of silence, we call it. This cone from the ground, it will keep increasing in width depending on how, depending on where the up to where the waves can travel. Okay, the higher you go, bigger the cone of silence. If you are on ground, cone of silence is only this much. But the higher you go, the cone of silence is more. So if you tuned into an NDB and you fly through it, and when you're over it, you'll not receive any signals. Or if you're receiving any signal, it is error. We should not be dependent on the signal. Even you will get to know, because when you get close to it, it will fluctuate, and then it will stay stagnant for some time and again fluctuate. So that means you entered, you were in cone of silence, and then you are getting back. Okay, so don't be dependent on your NDB in this cone of silence. Okay, even for VOR it happens. And when you are flying, you'll get to know if you happen to be lucky to fly with a VOR, and when you switch into VOR and you fly over the VOR, you'll see that fluctuation, the flags and all that will discuss in the VOR, what are flags and all those things. So that will happen. Okay, there will be a cone of silence above it. The diameter of the cone increases with aircraft height. Frequencies and types of NDB. The allocated frequencies of NDBs are 190 to 1750 kHz in low frequency and medium frequency bands. Since the mode of propagation used is surface wave, most NDBs will be found between 250 and 450 kHz. This answers your question. Mode of propagation is surface wave. Okay, it will travel through the curvature of the earth. Hence, mostly it is between 250 and 450 kHz. There are two types of NDB in use. Locator, these are low powered NDBs used for a feed or runway approach procedures and are co-located with and supplement the outer and middle marker of an ILS system. The normally have ranges of 10 to 25 nautical mile and may only be available during an aerodrome's published hours of operation. That is, so these ILS, like ILS is instrument landing system that will bring you to land. So when you are approaching and about to land, just few nautical miles, we are like 2, 4, 6, ऐसे कुछ. You'll have outer marker, middle marker, and inner marker. First, when you are approaching on the, if this is the runway and you are approaching, first you will hit a outer marker, then you hit a middle marker, then you hit a inner marker.
Okay.
So the need of these markers is when you are on the outer marker, airport has published when you are hit the outer marker, you should be at least this much feet high,
Okay.
not more or less than that. If you're less than that, you are too low. If you're more than that, you are too high for an approach. Then you can correct it. Then you hit the middle marker, again you should be at this height. Let's see, here it says 1000 feet, here it says 500 feet, here it says 200 feet. You should hit those things. If you don't, then your approach is not stable. Don't continue the approach. Okay? NDVs are being used there now.
Good.
Those will give you location, then the name locator, position. And the other one are en route NDBs. These have a range of 50 nautical mile or more, depending on how you design them. How much energy you give, how bigger antenna you give, that much they can send the signals to. Okay, 50 nautical or mile, and where serving oceanic areas may have range of several hundred miles also. Now, general route on land, 50 nautical or more. Now, you want to send these signals through ocean. You can't put a station in the middle of the ocean. You keep it at the coast and you give them more energy so that they can travel farther. So, over there, they'll have several hundred miles of range.
Okay.
Okay. So, there are no definite ranges depending on what purpose you use it for. You design it in such a way. They are used for homing, holding, en route, and airways navigation. Homing means to come to any airport. You are in the ocean, now you want to figure out where the land is or the airport is. Then holding means you are on a holding pattern. The station or the ATC has asked you to hold, circle around. You can use NDB to have, do that holding procedure. En route, to travel from one way to another, and airway navigation is also the same thing. Okay, those are en route NDBs. Your aircraft equipment. What will your aircraft have? This is what the ADF looks like in your aircraft. The previous one we saw NDB on the ground. This is the ADF in the aircraft which used to be there, not anymore. I haven't seen any ADF. Maybe some of actually I heard there are still some people using in some few old countries where they have not upgraded the technology or the equipments. But I have not seen them. Okay. Neither in India nor in Canada. If you happen to be lucky to see somewhere. Okay, the aircraft equipment compromises of a loop, aerial and sensorial. What are aerials?
Receiving item.
Antennas. Aerials is the another name of antennas. Okay. Then we'll discuss further into loop area and sensorial, how it works and all that. So, but basically it will have a loop area and a sensorial, a control unit which will receive the signal and amplify it, or put the information and take the information out of it. A receiver to receive the signals, you need a receiving antenna and a display. Now all this information is received. How will you give it to a pilot? Through that display. Right? So this is how it looks like. The areas you will have the frequencies. One, this is the frequency which he is currently using. This is the frequency on standby.
Okay.
Like I now I am going from this station and there is one more station next I have to switch to. So what will I do? I am using this, that next station already I put it here and set it so that when I have to switch I just have to press one button and it will switch to that station. Standby frequency. Okay. There are different buttons here if you see. ADF, BFO, frequency, flight, estimate and set or reset. Okay, all these buttons are. Then there is off and volume. If you turn it all the way to the end, it turns off. Then you turn it again, it will turn on, and you can increase the volume how much you want to listen to your Morse code. Okay, this is ADF thing. The to set the frequency. Now you wanna switch this frequency, you can use this button. So this is the ADF on display. This will give you the bearings. We'll discuss what bearings are. This will tell you the direction to fly or from which you are flying and all that. Okay, this is again all the frequencies set in it and the number, kind of transponder number and thing. Okay, we'll discuss each and every button now. Generally, it looks like that. Okay, in the aircraft. The frequency selector. This frequency selector will have two knobs. One big one on the outer circle, small one on the inner circle. If you see clearly, right?
Yes, sir.
The big one in the outer circle will switch the frequencies by bigger numbers. The small one in the middle is in zero point 0.5,
Got it.
like that. Now you want to set 3 to 3.5. You can take the bigger one to rotate to 3 to 1, 3 to 2, 3 to 3. Then you switch on the smaller one. Then it will give even points
Okay.
if needed. Kind of like that. Okay. Then this is the button to turn it off and on that we know. There is this, okay, ADF. If you are using the button ENT here,
Okay.
this means the ADF is not automatic. You have to switch into the frequencies manually
Okay.
when you are on that. If you are on the button ADF, it means it is automatic. It will automatically look for the signals around it. Okay, that's how you use those buttons. And there is one more button, ident. Is it there in this? ID. This is a test button to test if it is working on the ground when you are doing it. So that will be that for that. Now This is the ident button. They should have a button called ident. Actually, see, this is the old model. This is a new model with LED display. This is old model which you used to put it in analog display.
Okay, got it.
Okay, they are not. They are two different ones. They are not one system. Old one, new one. Okay. There is also ADF button on this. There is no ANT. It is already on ANT. There will be a button called ident also. So button for ident is when you press that button, it will give you the Morse code. It will not always be giving you. If you always keep, if you now you tuned it in frequency. If it always keeps giving you ident, then how will you listen to radio calls? Right? Continuously Morse code is also coming in, and someone is also talking in your. Will it make sense? It will be disturbing. So there will be button called ident. So whenever you press that button, that time only you will receive the Morse code. Once you identify the Morse code, you can turn it off again. Now you know you have switched on the right one. Now you can switch it off and then just use the EDF to work out whatever you want to do. Now you don't have to keep listening to the ident continuously. Once it is logged into a station, it's logged in until you change it. Correct? So that is the button of ident. So this ident, if it is not there, the BFO, this BFO works as an ident button. Okay, you can use the BFO as an ident button in ADF. The BFO, when you press the BFO button, you hear the Morse code, and you press it again, it will turn it off. That's what BFO is for. Or it will also be named as CW. If it is not written BFO, it will be written as CW. Okay. Now you know about all the buttons on the ADF. Any doubt in any buttons? Test button is just to test, make sure that ADF is working on the ground. Okay. Then there are the signals of this ADF. Okay, I think this presentation I had done for training the Indigo cadet program, so it's in very brief only, which is needed. Let's go back to CPL syllabus. The signals of this NDB will be of two parts: non E1E. Okay, two parts. One part is non, the other part is A1A. Okay. One second. Hello.
Yes, sorry. I do not know. But one of the things, I think it's one time payment. No, I said is it? The given per month.
Yeah. So the signal consists of two separate elements, the non portion and the A1A portion. The non part of the signal is, as we know, continuous carrier wave and is ideally situated to enable the ADF to establish the direction from which the signal is arriving. Okay, the non part will tell is a continuous carrier wave. We discussed there will be carrier wave and a signal wave. Like it is a continuous signal carrier wave. Okay, the non portion. It will tell you from which direction the signal is coming to your ADF. Okay, and the A1A part of the signal periodically replaces the non transmission and is being interrupted. Carrier wave is used to carry the two or three letter Morse identifier for the NDB. This is a continuous direction. This is continuous wave, this part.
Okay.
It will be continuously telling you where the signal is coming from, and it will display in that aircraft, and that aircraft will receive that signal and then continuously displaying as per whatever it is receiving. The A1A part is a part of carrier wave which is for short durations. It will be the voice part, the Morse code part.
Okay.
Morse code part will be your A1A. So every time you listen to the Morse code, whatever that 4 or 6 digit Morse codes are, you listen, break. Okay, this will be that, and you can turn this A1A part off, and you can just keep on continuous non part. Okay, so the two segments are non A1A part. The non part will be continuous wave telling you the direction, and the A1A part will give you the Morse code. This A1A part is normally used with high power output for long range NDBs. Okay, so but ICAO recommends to use non A2A, non A2A is for medium range.
So A1 is long range.
This is for long range. ICAO also recommends to use A2A for the long range as well, but we use A2A for usually medium ranges. Okay. Again, A2A part carries the Morse code identifier. Clear till now? Any doubts with the NDB, EDF, the frequencies, or how it works? Basic idea you have. We have to again discuss the antennas part and all that. I'll do that in the next class. So today we studied about what NDB is, ADF is, what frequency range it will operate in, and uh, ground station and the aircraft equipment, and how it looks in a aircraft, how it looks on ground, and how it will send signals, cone of silence, and then that ADF how it will look, what buttons are there, which button is used for what purpose, all those things we discuss. Okay, basically that's it. Any doubts? Read through these. Tomorrow we'll continue with the remaining portion. We'll read about how the antennas and how it receives signals and all that part, and what are bearings and all. We'll read that. Okay, and what are the errors in this instrument? All those things we'll read. Okay. Any questions? Anyone online? Okay. That's all for today. We'll continue tomorrow. Okay. Bye. I'll give you the metrology test. Yes.
Yes, sir. Then I can.
Yeah. Okay. Bye.
Bye, sir.
Bye. ಹಲೋ ಕಾರ್ತಿಕ್ ಮಲ್ಕೊಂಡು ಏನು ಇದು ನಿನಗೆ ಯಾವ್ದು ಮೆಸೇಜ್ ಬಂದಿದೆ ಅಮೆಝಾನ್ ಡೆಲಿವರಿ ನಂಬರ್ ಆ್ಯಂಡ್ ಪಿನ್ ಇಲ್ಲ ಇಮೇಲ್ನಾಗ ಬಂದಿರ್ತದೆ ನೋಡಿ ಎಸ್ ಎಮ್ ಎಸ್. ಅದು ಐತಿ ಈಗ ಹೊಸದು, ಇವತ್ತು ಡೆಲಿವರಿ ಆಗೋದು. ಆ ಡೆಲಿವರಿ ನಂಬರ್ ಪಿನ್ ಕಳಿಸ್ತಿದ್ರಲ್ಲಿ ಕಳ್ಸೋದು ಬಿಟ್ರೆ, ಯೂಶಲಿ ಡೆಲಿವರಿ ಪರ್ಸನ್ ನಂಬರ್ ಆ್ಯಂಡ್ ಪಿನ್ ಕಳಿಸ್ತಿರ್ಲಿಲ್ಲ ಅವ್ರು, ಡೆಲಿವರಿ ಪಿನ್. ಅದೇ ಮತ್ತು ಇದ್ರದ್ದು ಬಂದಿಲ್ಲ ಆರ್ಡ್ರದ್ದು. ಅವ ಬಂದನ ಕಾಲ್ ಮಾಡಿದ್ರು, ನಾ ಕ್ಲಾಸ್ನಾಗಿದ್ದ ಪಿಕ್ ಮಾಡಿಲ್ಲ, ಅದು ಈಗ ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿದನು. ಅಂದ್ರೆ ನಾಳೆಗೆ ಬರ್ತಾನೆ, ಬಟ್ಟಕ್ಕೆ ಊರಿಗೆ ಹೋಗೋಕೆ ಹೇಳ, ನಾಳೆಗೆ ಯಾವಾಗ ಬರ್ತಾನೆ. ಆಯ್ತು ಸರಿ, ಇವತ್ತೇ ಬಂದಿರ್ತದೆ ನೋಡಿ ಮೇಲ್ ಯೂಶಲಿ ಡೆಲಿವರಿ. ಆ್ಯಪ್ ಒಳಗೆ ತೋರಿಸಲ್ಲ ಅದು ಎಂದು. You can take some fighting break. ಸರಿ, ಓಕೆ.
Thank you for calling Amazon Delivery. Your call may be recorded for quality and training purposes. To speak to the delivery agent, please enter the 4-digit name for your delivery. No input received. Please enter a valid 4-digit name. This enter is invalid. Please enter a valid 4-digit name. delivery agent, please enter the four-digit name for your delivery. No input received. Please enter a valid four-digit name. Call has been forwarded.
Is Ravi here?
No.
He left.
Yeah. So in methodology, I had one doubt.
Yes.
So the first question.
One second.
So the first question, I don't know.
Is it not in the book? In the questions part?
But this one.
Where is that question from?
So my mom just googled